Demand for labor comes from the demand for the finished product. So we often call this derived demand. What that means is if the demand for the finished product increases, the demand for workers who make that product also increases. So we say we derive demand for labor from the demand for the finished product. Another key feature is the value of marginal product, which is VMP, or sometimes called MRP, marginal revenue product, refers to the value in dollars that a company earns in revenue when hiring one more unit of a factor of production, in this case labor. The VMP is equal to MPP, marginal physical product, times product price. So again, we're looking at when you add one more worker, how many more products can they make? And then also what's the value in dollars, VMP, by multiplying times the product price. And MPP is simply the value in finished product units that each additional unit of a factor of production creates when hired. Changes in the demand for labor are shown graphically by shifting the demand for labor curve left or right. Increase the curve to the right, decrease to the left. And the three factors that affect demand for labor are the price of the firm's output, which has a direct relationship, prices of other factors of production, which also has a direct relationship, and technology, either replaces workers or can help make them more productive. And if they're more productive in number of units sold or number of units produced, then they're also more productive in terms of dollar amount and VMP. And there's a typical demand for labor graph. Demand is downward sloping. Demand is equal to the marginal value of its labor, or VMP. And if you notice, the only difference between the product market, if you remember, and the factor market is the fact that wage instead of price goes on the horizontal axis if we're talking about demand for labor, because wage is the payment for labor. Going through one by one here, the price of the firm's output. So example is if we're producing yo-yos. If the price of yo-yos to begin with is $5 and the MPP of the last worker is 10 units, then the value of the marginal product is $50, $5 times 10 units. If the price of yo-yos increases, again, ceteris paribus, the VMP will increase and make each additional worker more productive than before. So if we take just the last worker, the price of yo-yos goes up to $10, the marginal physical product hasn't changed, but the VMP of that last worker is now $100. So in the labor market, demand is equal to VMP. If VMP increases, so does demand for labor. You might think of this as being price of other factors of production as substitute products. But instead of being products, it substitutes in production. So if the price to rent a crane increases by 50%, businesses replace cranes with workers, and therefore demand for workers increases. And technology can have two effects. Changes in technology either work to replace labor, therefore decreasing the demand for labor, or help them be more productive, increase demand for labor. Remember that the more productive a factor of production is, the greater the demand, because demand equals VMP. One type of union, and we'll discuss unions in a later posting, is called the demand-enhanced union. What it tries to do is to increase the demand for the final product, and therefore increasing the demand and wages for the workers. When we deal with equilibrium, we'll talk about wages and how they're raised, but if I add in a supply curve, which is still upward sloping, we started at demand 1, supply 1, so there's wage 1. We increased the demand for labor, so you can see their wages increased. And a good example of that is all the Got Milk commercials out there. It's produced by basically a union of milk farmers, and it works to increase the demand for the product, therefore increasing demand and wages for the workers.